Hi, everyone. Welcome to today's Research America Alliance discussion. I'm France Cordova, your moderator. For the next several weeks, we'll be hosting Alliance discussions featuring some of the honorees of our 2024 Advocacy Awards, and I'm looking forward to this conversation today. Thank you for joining us and for your partnership in the Research America Alliance. I'm very excited to introduce today's special guest, Dr. Robert Kahn, or Bob, recipient of Research America's 2024 Gordon and Laura Gund Leadership Award Alliance. Dr. Kahn, as you all know, has been a leader in academia, research, business, philanthropy, and national science and technology policy for more than 50 years. He's currently the Distinguished Policy Fellow and Pacific Rim Fellow at UC San Diego's School of Global Policy and Strategy. Dr. Kahn will discuss the role that American philanthropy has played in U.S. research and the unique advantage this has provided to allow America's research sector to flourish. Before we get started, I'll quickly remind our audience to please type your questions into the Q&A box or chat, and we'll pose as many as we can during the Q&A portion of today's discussion. So thank you for joining us, Bob. It's an honor to have you with us.
Happy to be here, France. Looking forward to the conversation.
Great. Well, Bob, you've had many different roles in the scientific community, including as an academic administrator, a scientist, and a leader of a nonprofit. Can you tell us how you became involved in national science policy?
Well, I think I always had an interest in policy questions, but I really didn't get involved until I became fairly well known in my technical field, which is fusion energy and engineering. And the first involvement really came during the 1970s energy crisis. Around 1975, when what today is the Department of Energy invited me and a colleague at Wisconsin, Jerry Kolsinski, I was at the University of Wisconsin at the time, to join a meeting to discuss the next big thing to build in moving fusion energy forward. And Jerry and I were founders in the 1970s of the field of fusion engineering. And the Department of Energy people knew us from that work, and they actually supported our work, our research. And nonetheless, it surprised me, and I felt they invited me to this first meeting in the mid-70s, and I went, and I was a relatively young person, hadn't crossed 40 for sure. And I was basically amongst the giants in my business. You know, every name was known to me. But that's how it started, and that was there was more in the late 1970s, and by 1980, I remember Congressman Mike McCormick from Eastern Washington District doing a congressional hearing and a big study on how to bring fusion energy to practice. And I ended up on that committee. That was a congressional advisory committee. So it was one thing led to another. You get networked, you get known, and that was basically how it all began, and it continued right on for the next 40 years or so.
Well, you really have an appetite for national science policy. And since you mentioned fusion energy, which is all in the news, of course, now with lots of breakthroughs, right, and its potential has really accelerated. Are you still advising on that? Or I know there's many other issues and we'll talk about it, but I'm
Sure.
Curious about fusion energy.
Well, I actually, I spent 30 years at the bench, let me put it that way, which means 30 years doing very detailed technical work. And then I got involved in administration, leading a school of engineering and building it up at UC San Diego. And I handed off my research program at that point to other faculty whom I hired in the business. And to this day, UC San Diego has a strong program in fusion. But I sort of got out of the business for 20 years or so. And I've recently got reintroduced to it. I was last summer on a trip back east, and I visited MIT's Plasma Fusion Center. And one of the spin-outs from MIT is attempting to build a tokamak machine, a magnetic confinement machine for plasmas, to reach ignition and burn. And of course, you know, France, there was a great achievement at Lawrence Livermore National Laboratory on the laser front, in which they were able to compress a tiny pellet of fusion-fueled deuterium and tritium, and actually compress it to the point they got propagating burn, like a burn front just in chemistry, and it burns through. And they got about twice as much energy back out as they had put into the target from the laser. So that was a remarkable achievement, and I think it's gotten everybody very excited. Similarly, in the magnetic fusion side, there have been great progress in fundamental understanding of the nature of when you make a very hot plasma, it's like the sun. It's much hotter than the sun, actually. And you have to confine it somehow. And the dominant way has been to use magnetic fields to control the electrified gas. But the heat and the particles of the gas do leak out. And we now have a fundamental understanding of the turbulence that gives rise to the heat and particle losses. It's just amazing. It reminds me of the 19th century and people like Reynolds coming up with Reynolds numbers and these other numbers about turbulence in ordinary fluids. So I think there is a very positive outlook when it comes to achieving the basic thing that's necessary. Get a hot plasma with deuterium and tritium, get it to ignition, and have it burn. I think that's pretty assured. How to do the rest of the system is what we spent the 1970s investigating. And it's a very difficult overall engineering and systems problem. We'll see how that goes.
Well, it's clear that science has really made you just a lot more proficient in your national science policy area. Let's transition a little bit to that, because it's you're unusual. There are a number of people now in national science policy, but it's not a big number, and being effective is especially important today. So could you talk a little bit about your history, especially your recent history, which I just find fascinating, of being involved in science policy issues, and maybe identify for our audience what you think are some of the prominent issues in science policy today, and why we should all be interested in them.
Sure. Well, maybe it's a good point to go back to the US's history and how science policy has evolved in our country. You know, there wasn't much science policy up until the Civil War. So the first 100, 200 years of both being a colony and then being a country, there wasn't a lot of science policy. During the Civil War, however, President Lincoln felt he needed the advice of the country's best scientists and engineers. And he had the idea, or his administration did, to establish the National Academy of Sciences. And the aim there was to both honor scientists, but also to develop a body of people who were distinguished people in their own right, really knew their technical stuff, but not directly involved with government, that the government could ask such a group for advice on science, technology, engineering, and ultimately medicine. And that's how policy really began. It didn't develop into a large business as it is today, if I could put it that way. Even during World War I, what changed was World War II. Science in many ways won World War II. Now, that's to take nothing away from all the troops who did all the heavy lifting to get us to the end game. But we got to the end game and won because of a lot of technical developments during the war, like radar, obviously the atomic bomb, and some others. And so what has developed in the country now, and how both you and I, France, have been involved, is that after World War II, the government really decided that engagement and support for science was critical. And it was critical both for our economy and our national defense. And it's been that way ever since. So today, we still have significant science issues in front of us. Science, in my mind, particularly basic science, but also basic technology and engineering, are at the forefront of new innovation. And most of the new innovation is what drives, at the margins, the development of our economy and produces the jobs and produces the high GDP that we have. So we need policies that will continue to drive science, and I use the word science writ large, science, technology, engineering, medicine, drive all of that forward. Make sure we have an innovation economy. Don't put too many constraints on what some people do so that we can really go look at the edges of what we understand. And if we continue to do that and drive the system forward, I think we'll be fine in terms of at least how our economy works and the strength of our national defense.
Most recently, you were president and CEO of the Kavli Foundation, very prominent philanthropic foundation in the United States that's made such a difference in so many areas. And we don't have time to go into everything they've done, but I want to talk a little bit about philanthropy and its role in national science policy. It's one, and you've made the point in several articles that it's one of the major components today, philanthropy is, in the research ecosystem, together with government and universities and industry. Could you describe the evolving landscape and the future of philanthropy and its important role in the research ecosystem and especially in science policy?
Well, as you say, I have argued that while government support writ large is fundamentally irreplaceable, the government must do what it does. Philanthropy has played a unique role in the United States in advancing both higher education and science and technology. And both your group and a group I was involved with both did a study recently of how much money does the government spend and how much money comes from those who are the performers of basic science, those at universities primarily, and some of our major private nonprofits like the Salk Institute, et cetera. And it turns out, if you sum the monies that have been given in the past, which end up in the endowments of our research universities, and current giving, and how the universities spend that money on science, engineering, medicine, technology, it turns out to be almost 40% of what the government spends every year. So I'm going to say that one more time. 40% of what the federal government spends. That's not ignorable. That's a big number. And so the money that is part of that 40% has come from historical giving, going back to the 19th century. And so philanthropy plays a unique and large role in the US innovation, discovery system in science, technology, and so on. I want to make a comment about philanthropy historically. You know, the United States has a unique system of public and private universities that's just not matched anywhere on the globe. How did that come about? Well, it turns out, if you look at the history after the Civil War, second half of the 19th century, yes, we had a Gilded Age, but many of the people who became very wealthy then gave much of it back. And many of our private universities were founded in the second half of the 19th century. Johns Hopkins, Stanford, Vanderbilt, Chicago, Carnegie and Mellon, and now Carnegie Mellon. They were all founded by philanthropists. And so today we have the greatest system on earth. And it's critical what they did in those days. And this is also due to philanthropy. Our universities in the late 19th century, mid to late 19th century, were all religious-based. Harvard was a divinity school, Yale, Princeton, you name it. These new universities were founded on a secular basis. And they were founded on a model of how professors and students would work together to advance all fields, and particularly science. You have a graduate school, you have a professor, the professor does work with the student does a PhD or a doctorate degree, and you sort of create a scientific infrastructure through people. We didn't have that prior to the new universities that were founded at the end of the 19th century. So philanthropy has not only been involved in supporting science, it has been involved in supporting higher education. And the outcome, I think, if you just look at it, is sort of obvious. Now, where should we go today? I would say, A, having this integrated innovation system of government support plus philanthropic support, an important thing is to make sure that you don't kill the goose that laid the golden egg. It's the combination that has given us the strength we have. I don't think government ought to try to control philanthropy, and I don't think philanthropy ought to try to influence government too much. What philanthropy needs to do and bring to the table is risk, what I call risk capital. Philanthropy, for the most part, is set up by individuals. When they pass, they often have a foundation that continues in the spirit of the founder. There are some great examples. And those foundations are nimble. They're much more nimble than government. So if you're a scientist and you have a wild and crazy idea, but you've got some basis for it, and if it turns out it's right or true, it might really change a field. You're more likely to get a yes answer in support of it from philanthropy than you might be from government. Government does take risks, I agree, but not to the degree that can be done with philanthropy. So we have a system whose risk tolerance is expanded by the presence of philanthropy, and where new things can be begun by philanthropy, and if they turn out to be really terrific, the government can take it over. And we've got many examples of that. So I would look at what we are as a system, and it has been extraordinarily effective, and I'm not sure I would tinker too much with it at this point.
That's great. So I think you're suggesting that young people who are involved in scientific research could turn to philanthropy for some of their wild and crazy ideas to get funded, right?
That's right. If they're young people and they happen to be at a university, let's just use that as an example because it's the most common example. And they may have some government support for the work that they're now doing. And then they have this wild and crazy idea I described. Now, how do they get it supported? How do they pursue it to see if there's a pony in there? Well, sometimes the universities can self-support it. I mentioned that 40% of what's supported is coming from the performers themselves, the universities themselves. So they can provide some support, and they often do. And that's philanthropy because the money came originally from giving in the past. But sometimes they can find a foundation that is interested in the topic and you only need a few $100,000, not millions and millions. They can make a decision in a few days if they want to fund such a thing. And you can be off to the races and find out, as I said, if there's a pony in the idea. So this is the way I would hope young people don't just think about government. Think too about foundations that work in support of what's going on in your area. You know, Research America promotes the funding in the health sciences. There's lots of opportunities aside government funding. And I think for crazier ideas, you're better off looking in the philanthropic sector than you are in the government sector.
Oh, that's great. Well, it's exciting just seeing all the different paths you've broken. I think of the Brain Initiative, which when you were head of Coffee Foundation, you pioneered, and along with the government, and that's was taken up by the White House, and is just so exciting. So you've taken, you know, both science and science policy to new level through your efforts. So we thank you for that. I'd like to turn now to audience questions. I'm sure you've stimulated a lot of them, Bob. And I want to ask Jacqueline to join us on screen. Jacqueline, any questions from the audience?
Thank you, Dr. Cordova and Dr. Khan. This has been an excellent discussion so far. So I'd like to turn to the first question. Can you talk more about the scientific discoveries that have been made possible because of collaboration between philanthropy and government-funded science? Are there any initiatives that you'd like to highlight?
Well, I think if I might start, France just mentioned one, and that's neuroscience. So the government in 2014, 15, and 16 decided to add about $500 million a year, net new money, to the NIH and some other agencies, including the National Science Foundation, to do new things in neuroscience. Where did that come from? How did that initiative come about? And France hinted at it. It came about from a partnership between philanthropies. In 2011, the Kavli Foundation, the Paul Allen Foundation, and a foundation in England called the Gatsby Foundation of Lord Sainsbury held a meeting and asked a pregnant question. What are the opportunities at the intersection of nanoscience and neuroscience? And out of that came a burst of creativity, the kind of crazy creativity I talked about, which philanthropy is naturally ready to support. And we did. When they decided to write a white paper, we provided the money for them to then travel back and talk to the government about this. And over a period of 12 months, the National Science Foundation, particularly in the National Institutes of Health, those were the two major players. They decided there was a pony in this idea. And the idea fundamentally was that so much is developed by way of technological instrumentation and sensing that we could develop new tools to make new discoveries in the brain. And I will tell you from experience, and French will confirm it, tools are everything. If you can't measure it, you can't know it. So by taking the initiative of developing first tools and then applying the tools to the biggest questions in neuroscience, we've made advances over the last decade that would simply not have been possible had that initiative not been undertaken. And where did it start? With philanthropy. And in fact, when the president announced that initiative, 3 or 4 major foundations committed big money in parallel with the government. We committed $40 million at the time from the Kavli Foundation. Howard Hughes Medical Institute committed $100 million. So it became something of a public-private initiative. but we didn't interfere with one another. We enhanced the initiative through our methods in philanthropy, and the government set up a big infrastructure and pursued it in a very good way at the government level, and with much more money. I mean, at some point, the government's got more money than the rest of us.
All right, thanks so much. That was excellent. I think we have time for just one more question from the audience. So Research America is an advocacy organization after all. Do you have any parting words or advice for science and technology advocates that you'd like to share before we end?
Well, if you're asking me, stay in the game. We're living in very troubled times. Nobody has to tell anybody that. We're divided, we argue with one another, and sometimes we get very angry with one another. It's not a good time in the United States. And nonetheless, we're a single country, and we're going to get through this. And science and technology needs to be supported by all factions, not just one side. So I think staying involved, staying engaged, and pushing the ball forward when it comes to science policy, and therefore the support of science, is maybe more important today than it's been in a long time. So get involved.
Great points. And we have actually another question that came in. Are there any challenges you see for the future of U.S. science funding that philanthropy can help address?
Franz, why don't you start with that, and I'll sort of add anything at the end, because you've got enormous experience in this area.
Well, there's so many challenges, and I think the philanthropy foundations, like the Kavli Foundation and many others, have really taken to heart the importance of those questions, the competition with other countries for leadership, for example, in AI and quantum and biotechnology, and they have a lot of efforts in there. They also are, just as you said earlier, just very open to new science. Recently, there's a collaboration between several foundations to fund tabletop experiments in physics on dark energy and dark matter, which is, you can see from my background, is really what I think about a lot. And so just doing new things. But I think one of the biggest things in my mind that philanthropy does is really pay attention to the individual or small groups of researchers, and especially emerging researchers, young researchers, researchers who want to change their understanding of something, and they've been maybe doing the same thing for a long time, but they have a new idea that is high risk and might not be approved right away for government funding. And they really have a focus on people, on investing in people, especially young and emerging scholars. And I just find that very exciting, because that's what's going to transform our future and really address some of these very important challenges that we face, from climate change, just food, energy security, and all. Let me turn to you for our final words on this, Bob.
Well, you spoke eloquently, and I really don't have anything to add to that. I mean, that is the summary answer to the question you asked, Jacqueline. So I thank my good friend, Dr. Cordova, for a comprehensive answer. I'll add no more, take no more time.
Well, we look forward to honoring you, Bob, in person at the Research
you.
America Awards ceremony on March 13th. And I want to make a quick announcement before we end today's meeting. And this is for our audience, to ask them to join us for our next Alliance member-only meeting on Thursday, January 18th at 2 p.m. Eastern. This is going to be an off-the-record discussion with Brian Fahey, who is Legislative Director in the Office of House Energy and Commerce Health Subcommittee. Chair of that is Brett Guthrie. And Brian is going to discuss Chair Guthrie's priorities for this key subcommittee, which has jurisdiction over many agencies, including NIH and ARPA-H and FDA. So if you're a Research America Alliance member, please email Jacqueline. Her email is in the chat if you haven't received the registration link. And thank you all for joining today's Alliance discussion. And thank you, Bob, for your leadership, which is just so sorely needed. We really appreciate it, and we congratulate you again on your award.
Thank you so much, France. Terrific.
Thank you. Bye.